Hello friends, myself Dr. Nandakumar Raubavale from College of Engineering Ambajogai is going to deal with fluid mechanics. So in previous class we have discussed about the horizontal plane surface submerged in the liquid, and numericals on a vertical plane submerged in the liquid, and inclined plane surface submerged in a liquid. Now today we are going to discuss numericals on an inclined plane surface submerged in the liquid. So now let us consider one numerical, a problem where he says that a rectangular plane surface 2 meter wide, width of rectangular plane is 2 meter and 3 meter deep, lies in a water. It is submerged in a water in such a way that its plane makes angle of 30 degree with the free surface of water. Then determine the total pressure and position of center of pressure when upper edge is 1.5 meter below the free surface. So here let us consider this dark blue line as the front view of this plane, and this is rectangle, which is the auxiliary view. When we see this plane from this direction, then its auxiliary view is a rectangle. So now this actually plane is here. So this dark blue line is the plane which is inclined to the free surface of liquid. So this is the free surface of liquid, to which this is making angle of theta degree. Theta here is given as 30 degree, and then he is saying that this edge C, so this upper edge in this front view is at 1.5 meter from free surface of water, and the width of this plate is 2 meter and depth this is 3 meter. Then he is asking us to find out the total pressure and position of center of pressure, that is H star and EF. Now we'll collect this information. So here it is given that the plane is rectangle and having width 2 meter, depth 3 meter, and it is inclined to the free surface at 30 degree, and the distance of upper edge is 1.5 meters. So this upper edge, this point C, means this upper edge is at 1.5 meter from free surface. This distance is x, so that is given. So he is asking us to find out the total pressure force and the center of total pressure force. Then to find out center of total pressure force, we have derived the equation F is equal to rho g a h bar. Rho is density of liquid in which it is submerged, g is acceleration due to gravity, a is the area of the plane, and h bar is the distance of center of gravity from free surface. So now rho, we know that is density of water, is 1000, g is equal to 9.81. area can be obtained. So area of rectangle can be obtained by using equation b is a is equal to b into d. Whereas to find out h bar, so to find out h bar, what we have to do is, you can see here, h bar is equal to x plus of d divided by 2 sine theta. D divided by 2, this is depth divided by 2. So this is d divided by 2 is 1.5. So now we consider this small triangle. So this small triangle, say this is this point is E, C and G, acceleration due to gravity, sorry, the center of gravity, CG. So this point we call as G. This triangle ECG is taken here. So this angle is theta. This angle is theta here. Then this distance is 1.5 meter. C to G is 1.5 meter. Now we want to find out EG. So total distance of this center of gravity from free surface h bar is nothing but this distance x. So distance from free surface to point M or point C this distance DC plus of EG. DC plus of EG is the distance of center of gravity from free surface. So DC we know that is 1.5. To find out EG we have to use trigonometry. So this angle theta is known as 30 degree. Theta is given. So now we can find out opposite side divided by hypotenuse is sine theta. So sine theta is equal to opposite side divided by hypotenuse. So we want to find out opposite side divided by hypotenuse. Hypotenuse is nothing but half of the depth d. So if this is the distance d, so half of that distance d is 1.5. That is nothing but distance CG is half of d. So therefore we can write this opposite side, that is opposite side in the sense distance EG is equal to hypotenuse. Hypotenuse is nothing but BC into sine theta. BC into sine theta. EG is equal to BC into sine theta. So now BC is nothing but d divided by 2. BC is nothing but d divided by 2. BC is divided by 2. Therefore H bar is equal to x plus of d divided by 2 sine theta. So from this equation we can find out H bar. So we know x is nothing but 1.5. The distance of upper edge from free surface is x, and d divided by 2 is depth divided by 2, that is distance C to G, and sine theta. So we know H bar, we can substitute H bar in this equation, we can get EF. Then the distance of center of pressure from free surface H star is given by equation Ig sine square theta H bar divided by AH bar. So H bar is known now, area we can find out, theta we know, sine square theta we can find out, Ig. Now the moment of inertia about the axis passing through center of gravity for this rectangle is given by BdQ divided by 12. So we know B, we know D, we know this 12 is constant, we can find out Ig, moment of inertia about the line passing through center of gravity. So if we know Ig, we can substitute it here, we can find out H star. So very first we have to find out A, Ig and H bar, then we can use F and H star equations. So let us solve it one by one. So area of rectangle, very first we want to find out area of rectangle. Area of rectangle is equal to B into D. B is 2 meter into 3 meter, which is equal to 6 meters square is the area. And second, which we want to find out is H bar. H bar is equal to X plus of D divided by 2 sine theta. So X is the distance of upper edge point C from free surface, that is point D, it is 1.5, plus of D, depth of this rectangle D is 3 meter, so 3 divided by 2 sine, this angle theta is given as 30 degree. On calculation we get it as 1.5 plus 1.5 into sine 30, that is 2.25 meter. H bar we get as 2.25 meter. Now we know H bar. Third, we need to find out IG, moment of inertia about the axis passing through CG, that is nothing but B d cube divided by 12. Now we know B is 2 meter, D is 3 meters, 3 to the power of 3 divided by 12. So 3 to the power of 3 is 27 into 2 divided by 12, which gives 4.5. This is IG is 4.5 meter to the power of 4. Now to find out F, we have to use formula F is equal to total pressure force, F is equal to rho G A H bar. We know density of water, which is 1000 kg per meter cube, into G is acceleration due to gravity, that is 9.81, and the area of this rectangle is 6 meters, into H bar. Just we calculated H bar as 2.25. So we get this as 1000 into 9.81 into 6 into 2.25. So this is going to be 1,32,000. 1,32,435 Newton, or this can be called as 132.435 kilonewton. Then to find out H star, distance of center of pressure, that is IG, sine square theta divided by AH bar plus of H bar. So this equation we have derived, AG sine square theta divided by AH bar plus H bar. So this second equation we are using. Now we have obtained IG value, that is 4.5 into sine square 30 divided by area is 6 meter square, into H bar just we have obtained is 2.25 plus of 2.25. So this we simplify as 4.5 into sine square 30 divided by 6 divided by 2.25 plus 2.25. So this is 2.33 meter. 2.33 meter is the distance of center of pressure from free surface of water. So this is one problem having rectangular shape. Now coming to the next problem, where the plate is inclined to the free surface submerged in the water, but the plate is circular. It is a circular plate having diameter 3 meter, immersed in a water in such a way that its greatest and least depth below free surface is 4 meter and 1.5 meter. So this 1.5 meter, as it is same as in the previous case, the value of x we call, and this distance from point B to free surface we call as y meter, that is 4 meter. So one edge is at 1.5 meter, another edge or another point is at 4 meter from free surface respectively. Determine the total pressure on face of the plate and position of center of pressure. So again here angle is not given. Instead of angle, these two distances are given. One end is at 1.5 meter from free surface, another end is at 4 meter from free surface of liquid. So this is the front view, whereas auxiliary view is circle. When we see perpendicular to this plane, auxiliary view we get as a circle. Now let us see what is given here. The diameter of circular plane is given, distance x, distance of upper edge or upper point from free surface is 1.5 meter. So distance point D to C, it is 1.5 meter, and distance E to A is 4 meter, that is y. Then we have to find out total pressure, force, and distance of center of pressure from free surface. So F is equal to rho g A h bar. Now h star can be obtained by same equation. So here the distance h bar we have to find out. H bar is equal to x plus of d divided by 2 sine theta. Again x we know, diameter we know, theta we don't know, so we have to find out theta. So in previous problem theta was given, here theta is not given. So to find out sine theta is equal to AB divided by BC. If we consider this triangle ABC, so in this triangle ABC, ABC, this angle is theta. Now the distance B to C is known as 3 meter. The distance AB we can find out. So how we can find out AB? So AB is equal to EB minus EA. AB, distance AB is equal to EB, so total distance E to B, minus of CD or EA. Now we can see EB is nothing but Y, and EA is equal to CD. EA is equal to CD, and CD is nothing but X. So distance AB is equal to Y minus X. Distance AB is equal to Y minus X. So Y value we know, X value we know. So sine theta is equal to opposite side AB divided by hypotenuse BC. So now AB we know, that is Y minus X, and BC is nothing but diameter of circle. BC is diameter of circle. So this is Y minus X, AB is Y minus X, and BC is diameter. Therefore sine theta is equal to Y minus X divided by D. We have this equation. We know Y, we know X, we know D. We can find out sine theta. From this sine theta we can find out theta also. So let us start with theta. Once we find out theta, we can find out X, H bar, then we can find out A, IG, and then F and H star. So we have to start from bottom to top. Very first we find out sine theta. Sine theta is equal to Y minus X divided by d. So y value is 4 meter minus x is 1.5 and diameter d is 3 meter. So sine theta is equal to 0.83. Sine theta direct, we are getting value of sine theta as 0.83. So need not to find out theta even. If we want to find out theta, so theta is equal to sine inverse of 0.83. So we get theta as 0.8333. We get it as 56.43 or 44 degree. Angle theta is 56.44 degree. So now we know sine theta value or theta also. Now we can find out h bar, that is the distance of center of gravity from free surface h bar, that is given by x plus d divided by 2 sine theta. H bar is equal to x plus d divided by 2 sine theta. So x value is known, that is 1.5 plus d value is 3 meters divided by 2 into sine theta, directly we know that is 0.83. On simplification we get h bar as 1.5 plus 1.5 into 0.83, 2.745 2.745 meter is h bar. So now we know h bar. Now we can find out area Ig. So area of circle pi by 4 d square, pi divided by 4 d square is 3 square, 9 into pi divided by 4, 7.06 meter square. This is area. Then we have to find out Ig, that is Ig moment of inertia for circle is pi by 64 d to the power of 4 pi by 64 d to the power of 4 pi divided by 64 into d to the power of 4 so this is pi into d to the power of 4 divided by 64 gives us 3.976. Three point 976 meter to the power of 4. So now we know area, we know h bar, we know Ig. Now we can find out force F. So everything is known, h bar is known, area is known, Ig is known. We can find out F and H star. So therefore total pressure force F is equal to rho g a h bar. Again here there is a water, liquid is water, therefore density is 1000 kg per meter cube. Acceleration due to gravity is 9.81 into area, just we have calculated as 7.06 into h bar, which we have calculated as 2.745. On simplification we get it as 1000 into 9.81 to 7.06 into 2.745. So this is 190, 114, 1,90,114.85 Newton, or this can be written as 190.114 kilonewton is the force. Then H star, center of pressure H star is equal to Ig sin square theta divided by AH bar plus of H bar. So now we know Ig value, which we obtained just now. Ig is equal to 3.976, which we have calculated here. Then into sin square theta, sin theta value we know, that is 0.83, 0.83 square divided by AH bar. The area of circle is 7.06. H bar. H bar is 2.745 plus of 2.745. So we get H star as 3.976 into 0.83 square divided by 7.06 into 2.745 plus of 2.745, 2.886. 2.886 meter. So this is H star, or distance of center of pressure from free surface of this liquid is given by 2.886 meters. So now coming to the next numerical. Here it is based on triangular plane. Find total pressure and position of center of pressure on a triangular plate of base 2 meters. So base is 2 meter, whereas the height of triangle is 3 meter. It is isosceles triangle which is immersed in a water in such a way that plate makes an angle of 60 degrees. So theta is given with free surface of water. The base of plate is parallel to the water surface and at a depth of 2.5 meters. So this base is 2.5 meter below this free surface, that is distance x is given. So theta is given, x is given, and the dimensions of triangle are also given. So to find out this, what is given here, base of triangle is 2 meter, height is 3 meter, and this edge is at 2.5 meter from free surface, that is distance x is given as 2.5 meter and theta is given as 60 degree. So here we have to find out total pressure force and the center of pressure force H star. So to find out that, we use H is equal to rho g a h bar, and H star is equal to Ig sin square theta divided by a h bar plus h bar. So for triangular plane, to find out Ig, moment of inertia about the center of gravity, about the line passing through the center of gravity, is given by bh cube divided by 36. So here area is given by a 1 by 2 bh, area of triangle, and h bar is nothing but x plus ag. So this distance a to g into sine theta. So here also, if we consider ag and this point as say c, AGC, in this triangle AGC, AGC, so we want to find out distance CG. So this angle theta is known. So this distance A to G we can find out, distance A to G. So this point is say A to G. So center of gravity of a triangle from its base is at 1/3 of its side, h by 3. So AG is h by 3. Theta is known, 60 degree. Now we want to find out CG. CG is nothing but CG is equal to AG sin theta. So sin theta can be written as sin theta is equal to opposite side is CG divided by AG. So that is CG is equal to AG sin theta. So CG is equal to AG sin theta. So once we know CG, distance C to G, from C to surface, that is x. So total distance h bar is x plus ag sin theta. So ag sin theta means that is the replacement for cg. So once we know h bar, a and ig, we can find out f and h star. So let us start with h bar. So h bar is equal to x plus of ag sin theta. X we know that is 2.5 meters, which is given in the problem itself. X is 2.5 meter. AG distance, AG is h by 3. H means height is 3. 3 divided by 3, that is going to be 1 sine 60 degree. Theta is given as 60 degree. So AG is equal to h divided by 3. H is height of triangle, h divided by 3. The center of gravity is at h by 3 distance from its base. So this distance is h by 3. Now if we simplify this, .36, h bar is known now. Then area of triangle is half b into h. So half base is 2 meter, into h is 3 meter. So 2 gets cancelled directly. 3 meter square is the area triangle. So this is area is known now. Now we can find out Ig is equal to bh cube divided by 36. Bh cube divided by 36 for triangular plane. Ig is equal to bh cube divided by 36. B is 2, h is 3 cube divided by 36. Ig, that is moment of inertia about the line passing through center of gravity of a triangle parallel to the base of the triangle, is given as bh cube divided by 36. This works out to be 1.5 meter to the power of 4. Now we know h bar, A and Ig. Directly we can find out F, that is total pressure force. F is equal to rho g A h bar. Rho is 1000, g is 9.81 into area of triangle, which we obtained as 3 meter square, into h bar we obtained as 3.36. So we get it as into 9.81 to 3 into 3.36, 98,000. 98,884.8 Newton, or this is 98.88 kilonewton. Then H star, center of pressure, that is Ig, sin square theta divided by AH bar, which we have derived in previous class, plus of H bar. So now we have obtained value of Ig. Ig is equal to 1.5. Sin square theta, sin square 60 divided by area of triangle. Area of triangle is 3 meter square, into h bar is 3.36 plus of 3.36. So this gives us h star, (1.5) into sin 60 square divided by 3 into 3.36 plus of 3.36. This is 3.47. 3.471 meter. So center of pressure is H star is 3.47 meter from free surface of liquid. So this is how we have seen three numericals on three different shapes of a plane, that is rectangle, circle, triangle. So it depends on the shape of a plane, the total force exerted as well as the distance of center of pressure depends on the shape of the plane. So here we stop, and in next class we'll discuss about the total pressure force exerted on a curved surface as well as center of total pressure from free surface of liquid. Thank you.